In this lesson, we're looking at stopping distance. So this is when we're talking about driving, if you need to brake suddenly, how long it could take you to actually stop. So if a child ran out onto the road, or if you had to brake suddenly because someone walked out onto a pedestrian crossing. So it's about using some of these formulas and knowledge to know how long or how far it could take you to stop. So our reaction time is the time you take from seeing the hazard until putting your foot on the brake. So seeing a hazard until putting your foot on the brake. So how quickly you can react to something changing in front of you. Your reaction distance is the distance that you've travelled, so the distance travelled during your reaction time. So how far, if you're going 60 kilometres an hour, how far did it actually take you to stop? Our braking distance is the distance you travel from when you put your foot on the brake until your car comes to a complete stop. And then our stopping distance, which is our reaction distance, plus our braking distance. So our braking distance formula, so the approximate braking distance, which is distance in metres, is found using D equals kV squared, where V is the kilometres per hour of the initial speed, and K is a constant. So when we think about that variable, we find that constant, and then we can use that to work out what we need. So our speed and road conditions, and the braking distance changes with the road. So if it's wet or icy, it's going to take you longer because you are going to skid as if it was a dry day. So if we have our example, Ben drives a Holden car and has a reaction time of 1.3 seconds. He was travelling at 60 kilometres an hour when he saw an accident up ahead. He put his foot on the brakes and stopped 18.7 metres later. So the first thing we're calculating here is his reaction time. But what I need to do, because I have his reaction time in seconds and our travelling speed in kilometres per hour, I need to change my kilometres per hour into metres per second. So if I think about converting, so I have 60 kilometres per hour and I need to turn it into metres per second. So how many metres in 1 kilometre is 1,000? So if I had 60 times 1,000, that's going to give me 60,000 metres. And then I need to convert my hours into seconds. So we know that there are 60 minutes in an hour and there are 60 seconds in each minute. So if we say 6 and 6 is 36, and then our 2 zeros, so 3,600 seconds per hour, which is another good piece of information to know. If I calculate that, I get 16 2/3 of a metre per second. So what we're now calculating is that reaction distance, which if we think back to above, our reaction distance is the distance travelled during our reaction time. So the distance that we travelled is 16 2/3, and our reaction time is our 1.3 seconds. Okay, and that is going to give us 21.66666 forever. So that would be 21.7 metres. So that's how long it took for Ben to actually react at that time. The next is his stopping distance. So his stopping distance, if we think about the formula above, it said the stopping distance is our reaction distance, which is what we've just calculated, so 21.7, plus the braking distance. And if we look in our example, our braking distance is 18.7. So if I put those together, that gives me 40.4 metres. So it took Ben 40 and a half metres almost to come to a complete stop when he saw this accident. So using the braking distance formula, which is D equals kV squared, where K is our constant and V is our kilometres per hour, we need to find the value of K. So D, which we've calculated, or we have as our stopping distance, our original braking time. So D is 18.7. We're finding K and our speed is 60 kilometres per hour, so 60 squared. So what we now think about is how do we solve this equation? So I need to have k left on its own. So this is multiplication, so the opposite is to divide. And I'm going to divide both sides by 60 squared. So that is going to give me, I'm just going to flip k over to this side. So k is 0.005194 repeater. But I want this to two significant figures. So that means I want two numbers after all of the zeros in this case because it is a small number. So 0.00 and I'm going to get 52. And that's to two significant figures. The next part says find the braking distance when travelling at 75 kilometres per hour. So to find the braking distance, I need that reaction distance. So for that, I'm going to have my reaction distance, so 75, turning that into metres per second. I times it by 1,000, and hours we worked out before was 3,600. And I multiply it by that 1.3, which was the reaction time. So if we work this out, we get 27.1 metres, and that would be our reaction time if, for instance, he sped up to see maybe he wasn't sure what was going on, that's 75 kilometres, how that changes. So our reaction distance, if we were going 60 kilometres per hour, is only going to be 21.7, whereas now we're looking at 27.1. So we've added an extra 6 metres just by increasing our speed by 15 kilometres. So now we're finding the stopping distance. And to do that, what I first need to find is the approximate braking distance. So I need to go back and use this formula. So with this, we're trying to find what D is for that stopping distance. So we've got our constant, which was 0.0052, and I'm multiplying it by our speed squared, which was 75. So that tells me that's 29.25 metres. And I'm going to use that here. So my reaction distance is 27.1. And my stopping distance here is 29.25. I add them together, I get 56.35 metres. So you can see the difference from that first example when we're going 60 kilometres. It took 40 metres to actually come to a complete stop. Whereas adding that extra 15 kilometres, it's actually taking me an extra 16 metres to stop. So it really goes to show how speed can affect your driving and that stopping time. So the last part here says the speed of a vehicle find the speed of a vehicle with a braking distance of 100 metres correct to the nearest 100 kilometres per hour. So we think about this same D equals KV squared formula. So we have D equals KV squared. So our braking distance is 100. We know what our constant is. We've worked that out, which is 0.052. And I'm trying to find what that speed is. So I'm going to solve my equation. So divide by 0.0052. Do the same to both sides. And then I'm going to find what V is by putting all of this into, all of the left-hand side into a square root because it's V squared. So in order to find V, I need to find the square root. And the reason I'm going to do this all in one go is so that I don't end up with any messy decimals, which might change my answer slightly. So if I put all of this into my calculator, I get 138.675 continued, but I want it to the nearest kilometre. So it's going to be 139 kilometres per hour.